Alright, hey everybody, and welcome to our next video over central angles and arcs. What I'd like for you to do is try this warm-up problem. Using the following formulas, find the area and the circumference of the circle. Alright, so 5 is the radius, so I would use pi r squared to find the area, so pi times 5 squared. And then for circumference, I would use 2 pi r since we're given the radius, and that would give me 10 pi centimeters. Alright, so as I said, this video will be about central angles and arcs. So there's some vocabulary terms that we've got to talk about. In this circle, this is circle C, because remember we name circles based on their center. There is an angle ACB, and the vertex of angle ACB is the same as the center. The vertex sits on top of the center of the circle. Therefore, this angle measure here is called a central angle. The way I know that is because the vertex sits on the center, so it's a central angle. Now, if you were to take a look at this angle, okay, it cuts the circle into two pieces. It cuts it into this piece right here and the big piece all the way around. So I'm not going to do a great job at this, but you'll see what I mean. So there's a smaller piece and a bigger piece. And what we actually call those, or we call those arcs. So anytime you have a piece of a circle, think of this would be like a pizza. And you take a slice of pizza out and eat everything but the crust. Okay, the crust you hold in your hand would be an arc of the pizza that you have. Now, we name arcs with either 2 or 3 letters, and we measure them in degrees just like we do angles. Now, a minor arc is only going to have 2 angles, or 2 letters. So if we look here, AB, this is arc AB. I'm going to use the blue pen. AB. That's the arc here. Now, because it has only 2 letters, it's a minor angle. So and the minor angles are going to be less than 180 degrees. And that makes sense because arc AB here is less than half of the circle. Now, when we talk about major arcs, these are going to be arcs anytime that it's larger than half the circle. So in this case, ABC or CBA. So if we go back to our first example, this red arc was our major arc, and we actually have to give it a 3rd letter in order to show that it's a major arc. So this red arc would be arc ADB. And basically what you would do is you would follow the starting point, it passes through point D and stops at point B. If it doesn't have 3 letters, we might confuse it with arc AB, the small blue one. And we know that it's 3 letters ADB, the major arc. So that's why we have 3 letters for a major arc and 2 letters for a minor arc. Now, we have a semicircle, and this is any time that I draw a diameter, and then the points, if I go one arc from the point of one diameter to the point of the other diameter, it's going to be a semicircle. Okay? Semicircles can be either named with 2 or 3 letters because it doesn't really matter since they're exactly 180 degrees. Alright, so the measure of a minor arc is going to be equal to the measure of its central angle. So let's come up with an example. What about 35 degrees? Since angle ACB is 35 degrees, then arc AB must be equal to 35 degrees as well. Arcs are equal to their central angles. Okay? Now, the measure of the major arc is going to be 360 minus the minor arc. So, because the whole circle adds to 360, and I know this blue piece is 35 degrees, then arc ADB will be 360 divided by 35. Or minus 35. I don't know why I said divide, that's so weird. So 325 degrees. Alright, so let's go ahead and put that into practice. We have some central angles here. Angle CDB is 135 degrees, or 130 degrees. ADB is 50 degrees. And what you'll notice is this is a diameter. So this whole angle is 180 degrees. Now arc AB, 2 letters means minor arc. You start at A and you go until you stop at B. Now that's the arc we're looking for, and it's going to be equal to its central angle of 50 degrees because this angle here makes arc AB. Now BC, you start at B, you travel all the way to C, and the angle, the central angle that makes that arc is measured 130 degrees, so the arc must be 130 degrees as well. AEC, so this is either going to be a semicircle or a major arc. So AEC, so I start at A, I go to C in the way that passes point E. So because it covers exactly half of the circle, it's 180 degrees. Alright, so I'm going to erase these. Oops, I wish I had left that. There we go, I'll write it back. Alright, so now we have angle B, or arc BCA. So we start at B and we want to go to A. But notice there's 3 letters, so it's a major arc. So we go from B to A, but in the way that passes point C. So I had to go all the way around. So I have the entire circle except for this 50 degrees. So you would do 360 minus the 50 degrees. So you get 310 degrees. Now another way to do this problem, instead of saying subtract from 360, I could have added 180 and 130. And if you add 180 and 130, you still get 310 degrees because this big green arc was made by both the central angle of 130 degrees and 180. Now this is actually called the angle addition postulate. What that means is if I have 2 angles, let's say here's AB, and here's BC. These are the 2 arcs that are congruent to their angle measures, say 40 and 60. How about that? That the arc ABC, so all the way across AC, must be equal to the 2 arcs added together. So the blue arc will be 100 degrees. Alright, so let's put that into practice. First thing you'll notice is that I have 3 out of 4 central angles. What I need to do is do some math here and go ahead and find the central angle that's missing. So I would do 360 minus 120 minus 70 minus 80 to get this missing angle here. So let's do that right now. Alright, so I found this to be 90 degrees. That's what the angle should be to make all of these add to 360. Alright, so arc DG. So I start at D and I travel to G in the shortest way possible because it's only 2 letters. So I cross the angle that's 80 degrees and I cross another angle that's 70 degrees. So 70 plus 80 is 150. Alright, I'm going to erase this. DGH. So D to H, but making sure that we pass through G. Alright, so 80, 70, and 120 are the 3 central angles that I meet, or that I pass. So when I add them up, I get 270 degrees. And now D to H, remember 2 letters is minor arc, 3 letters is major arc, so D to H is here. Its central angle is 90 degrees, so the arc must be 90 degrees as well. Alright, why don't you take a minute and try to find the measures of these 3 arcs. As a reminder, remember that BD is a diameter, so you may have to flip back to what you know of as a semicircle. Alright, pause and give it a shot. Alright, so let's take a minute and talk about how we got our answers. First off, this is 180 degrees because it's a semicircle. So 360 minus 180 minus 148 gave me the 32 degrees here for angle BAC. Now arc CD is here, and it's made by the central angle that's 148 degrees, so its arc measure must be 148 degrees. CDB is a major arc, so I add 148 and 180, and I get 328 degrees. And BCD is 32 plus 148, or 180 degrees. Alright, pause here and give this second example a try for yourself. Alright, so hopefully you can check your answers, see what you did. Alright, so next thing that we're going to talk about is actually congruent arcs. Congruent arcs are just like congruent angles. Two congruent angles have the same measure, so two congruent arcs have the same measure. Now, congruent arcs must either be made from the same circle or a circle that is congruent, meaning that it has the same radius. So taking a look here, I have two vertical angles here and here that are both 30 degrees. Therefore, the arcs they make, AB and DC, must both be 30 degrees. Because AB is made by the central angle AEB, which is 30, therefore AB is 30 degrees. And DC is made by the central angle DEC, so its measure is 30 degrees. Therefore, the two arc measures are the same. Now, if we take a look here, this arc BD is made by the central angle BCD, 45 degrees. So this arc measure is 45 degrees. Now, if we take a look at AE, oops, that was not even close to the circle, was it? I'm not doing a great job today, guys. There we go. A little bit better. This right here is made by the same central angle ACE, 45 degrees, so its arc measure is 45 degrees. But why are they not the same length? That's because if you were to take a look at this circle, this radius is smaller than the radius of the bigger circle. So this radius would then continue farther out. So while they have the same measure, they are not congruent because they're not made from congruent circles. So let's put that to the test. Determine in A, B, and C if arc AB and arc CD are the same measure and explain why. Alright, so hopefully you paused and now you're ready and rocking and rolling, ready to go. Alright, so AB and CD are in the same circle and they're made by the same degree measure, 60 degrees, so these two arc lengths are congruent. In question B, arc AB and CD have the same measure of 135 degrees and the circles have the same radius, so the circles are congruent, therefore the arc lengths are the same. Now in question C, AB, and CD have the same measure, the same degree here. However, they don't have the same radius. Therefore, they are not congruent. Oops. Alright, well that's it for central angles and arcs. I will talk to you guys later.